Hello everyone. My project is Higgs boson classification using H2O Deep Learning API. The background of Higgs boson. Higgs boson is an elementary particle in a standard model of particle physics. To generate a Higgs boson particle, we need the particle accelerator. Once the data is collected, one need in this research field is to distinguish the Higgs boson generating signal process from the background process, which doesn't generate Higgs boson. So this classification issue sounds like it's a good area to apply deep learning approach. So in my project, in fact, I applied the H2O Deep Learning API to resolve this issue. So try to do that. We need to first download. Let's first have a look at the dataset. In fact, the dataset is from UCI Machine Learning Repository donated by Professor Daniel Whiteson. It's a pretty huge dataset. It has 11 million rows and the last 500K as a test data. So to do this project, I take a sample 100K as a training and 10K as a tested site. The data looks like this. Totally is 29 columns. The first column is a label to tell you that either it's a Higgs boson generating uh, generating signal process or it's a background. 0 means a background, 1 is a Higgs boson generating process. And then the other 28 columns are features. They all features. That the first 21 is raw feature, and the last 7 is a calculated feature, derived feature from the 21 raw features. Okay, this is the column names look like this is the derived features. Okay, now H2O Deep Learning API, in fact, is one of the outstanding machine learning platform. It has a very excellent implementation of a wide range of machine learning algorithm like general linear models, random forest, GBM, deep learning, etc. And it has API for R, Python, Spark, even TensorFlow, all these popular platform and languages. Okay, so for my project, I use the H2O and R. To install H2O, you go to their website, okay, to download this zip file, and then you unzip, and then uh, from command window, you need to kind of run this jar file to run it as a background service. This is what, in fact, I'm running here. Once you started this background process, you can invoke from R. Okay, so this is this is loading the data part. Okay, to load the data, like at the beginning, I loaded from like this Higgs data site, and then I take a sample, 100K sample and 10K as a test. So once you load it, you need to connect it to the H2O API. So this is how we do. The first time you need to do one install package. It's just like regular R package. You need to install one, and then you import the library, and then you connect it to H2O. You use this one H2O init to connect to the to this background service. Once you connect it, you can invoke all these machine learning API. Okay, so for data satellite, we first need to convert the R data frame to H2O data frame. This is the syntax, and then we do we need to convert the label to factor data type to do classification. If we leave it, it will be do regression. So you need to convert it to factor to do the classification. And then we just assign this is our target column. This is all the feature column. As simple as that. And then this is we can just write it to build the first deep learning model. Okay, so this is the first deep learning model we built. It takes, I think, maybe 1 or 2 minutes. So I hear that I'm not running it. In fact, I think let's running it once. Maybe it's okay. Let's see. Okay. So it will take some time. I will pause a little bit. So as we can see, in fact, this is this is warning is in fact I set this one. In fact, the by default they have automatic set another parameter is adapted rate. Okay, so this is to build the first model, and after that, what I did that I use that the, of course, in fact mm, we can look at the accuracy, the precision, the F1 AUC, and the confusion matrix. Okay, all these metadata you can pull from like H2O machine learning API. So after that, what I did is I use that the H2O grid search, to search for the hyperparameter. It has, I think, hundreds of different hyperparameters. I only searched maybe 3, 4 of them. So, for example, this first grid search, I try to see what hidden layer combination and L1 regularization is is the most is the best. So after feeding, this is the grid searcher syntax. So totally, we'll build in fact the 8 model. It's 4 by 2. You build 8 model. After you build the 8 model, this is the 8 model you build, and you will get basically like use like uh, we can sort it. In fact, we can sort it once. You can give like uh, what's your measure you want to sort it. So for example, I use accuracy. I sorted by accuracy like descendant. So for this one, this combination, I get the best, the best accuracy for this run. In fact, I ran it multiple times. Okay, and for this one, like you get the worst. Seems like okay. For hidden layer combination is not that much clear which one is better, but for L1 regularization, the 0.0001 is the best one. So we can use this one in the next search. So in the second search, okay, I use this L1, and then I try to find the L2, so on and so forth. So I did three times search. After 3 times, okay, the third time I try to find like the best epoch. Um, so after that, in fact, we I take like all these hyperparameter I found from the grid search to build a final model in this project. So this is the final model. I built like this 4 5 like parameters hyperparameter I got. After that, like we can run this model to build this model once. Um, we can in fact after build, in fact this is the build, we can like to see that what's the accuracy, what's the uh, AUC. So AUC is 80.6% and the accuracy is 71%. This is for the testing data. For the train data is a little bit better than that, maybe 2% better. So we can also see uh, pull from that H2O API all this metadata. For example, this is the log loss by epoch. Also, we can we can find out which feature is most important or most impacting. So this is the feature relative importance. We see WBB. This is a derived feature, uh, and who is the least. So this is what tell. Now after building all these models, we can also utilize H2O interface. So this is let me reload once. This is the H2O interface. You can get models. Okay, so this will give you, this is all the models the grip search grid search I got. Um, and if we want to see one is, okay, we can add add one cell, and then we run it. The model will be pulled. So this will tell us later what is the log loss. Okay, the blue one, in fact, it is uh, training, and the orange one is the test. And also we can see that's the AUC graph, and for training, for testing, and then this is again the feature importance. So all here. Okay, we can even get much more information than that. For example, you can get the grade. So this is that the grade that we build. In fact, it's 8 model. I ran it twice. You get that is totally 16 models here. So each one that you can just to see that how it performance. Okay, so this one is like this. Okay. Um, Another thing that I like to mention is mm, I also I also use like this H2O Generalist AI. It's an automatically platform to analyze the data set and then to build the model for you. To use this one, you need to, in fact, it designed it for like a GPU machine. Since my machine doesn't have a GPU, but it does have a way to use like the CPU machine. You need to install the Docker, and then install this. You just download this Generalist AI and install it. So after, in fact, I run my Docker, and then I installed. After that, I can run this Generalist AI UI. Okay, so here, like, you can add some data set. Okay, choose one, like one. I already loaded one, so this is already set. After loading one, in fact, uh, you can kind of like to do some visualization to see that how data set is look like. It takes maybe 1 minute to pull this analyze. So it start coming. So this is just a data side analysis, just like what we did as a histogram, or what we did in R. But here that it does for you automatically. So it tell you like who is which feature is skewed feature, and you can see the correlation and all this. You can click one like to see the detail. Okay. Now after you load the data set, you can do experiment. Basically, he build the model. You can create that new experiment. It takes quite some time. In fact, you need to give like you need to give the choose the data set, and to give like the target column. Okay. Let's see. Seems the machine is slow. Okay, so in fact, I already built like one experiment. It takes this one takes 22 minutes. So here we don't have time to review. Let's just have a look at like this uh, experiment I already did like beforehand. So what they did, in fact, it also like trying to build like a model to search for the I think the better parameter, and then keep building. So the final model I built is 80.6% AUC. It's pretty much the same as what we built from R using H2O API. That's also, I remember, is also 80.6. So it's almost same thing. And after they build this, you can also interpret the model. It gives you some more details, like tell you like how like each features like go, and also give you this feature importance. As we see, it's pretty much agree with what we build. So this is a Generalist UI. So as a conclusion, I just want to in fact I highlight all these parameter is output here. But as a conclusion, this H2O data learning API is very easy to install and very easy to invoke for different programming language like R, Spark, and Python. And the training speed is very fast. I think I totally take maybe 15-20 minutes to do that the grid search for hyperparameter 3 round and then build a final model. And the accuracy and AUC, in fact, for this data set, this is a pretty good one. It's a competitive one. And as we see, it's a kind of like a good use. And once you build the model, all this metadata detail you can pull from like the API. You can program from R. Okay, from Python, from Spark is the same thing. Some like cons, I think I at the beginning I tried to do with Spark, but the online documentation example seems not that good as R. So finally, I implemented in R first. So that's the reason I use R for demo. Another thing is that this user interface is very good, but seems a little bit less customization capability. So overall, in fact, it is a very, I feel it's a very good machine learning platform to use. And if I get time, I will try to see that this accuracy, this model accuracy can be improved, or for this data set, it's just like that. So thank you very much.